Hey everyone, welcome to another dotnetFlix. Today our guest is Willem Meints.
Good morning.
And we're going to talk about ML.NET, right?
Yeah, that's correct. Yeah, so today I'm going to talk about machine learning in C# using ML.NET.
Okay.
So it's a pretty interesting framework because normally when I talk to people about machine learning and AI, it's usually in Python or in R. I don't personally use R, but most people will start to use Python. And a lot of the .NET developers that I've met said to me, well, Python, I don't know about that. Let me do C#. That's better. So 2 years ago, Microsoft released a machine learning library called ML.NET, which is based on work that they've done internally at the Bing search engine, Xbox, Windows, those departments. So they use it internally. So it's something that they have used in practice and it's proven.
So it's
and now it's released to it's made open source, so you can use it. At the moment it's version 1.4, so it's pretty young still. There's a lot of stuff still happening, and they are adding more features, more models to the library. So today I want to show you something called the model builder that makes it really easy to get started as a C# developer. So normally, when you build a machine learning model, you have to do a lot of pre-processing to your data. You have to clean up your data set. You have to spend a lot of time figuring out, is my data set well balanced? Does it represent reality? To a certain extent.
Because this is necessary to do successful AI machine learning stuff, right?
Yeah, to make it worth its weight. You spend a lot of time, so it has to be correct in the end. Today we're not going to do that. We're going to skip all that. Because that's a lot of work that a data scientist has to do. This is aimed at developers. So we're going to use the model builder. The model builder allows you to build a model in a few steps. And the computer will figure out all the pre-processing, all the balancing, all the stuff that a data scientist normally does. So it's pretty cool.
This will definitely lower the learning curve for, let's say, regular C# developers to get into machine learning.
Yeah, I think ML.NET is great for people that want to use machine learning to solve a particular problem that's unsolvable using normal if statements or normal business rules. That's my goal also for this talk. So.
And this is based on .NET Core, right? So you can
this is cross-platform, so you can use it on Mac, Windows, Linux, on Xbox even. That works too. Yeah, I don't know why we do that, but it works. It's .NET Core based, so it's pretty new and pretty cool, I think, for developers. Yeah.
Oh, let's dive in.
Yeah.
I'm pretty excited to learn about this.
As Microsoft explains themselves, it's machine learning made easy because they've included automated machine learning. That's what we're going to use today. But you could do it manually if you wanted to. So if you get a model out of this automated machine learning that doesn't help you, you can tweak it and try training it yourself if you want to. It's also good to know that it's not just for building models in C#. If you've got a model that's made by a data scientist in Python using TensorFlow, for example, you can ask him or her to save it to disk and then import it into ML.NET, and you can make predictions with that.
Okay, so now you've got this nice separation of concerns across the different roles.
Yeah, that makes it especially useful, I think, in larger teams and companies that want to go to production actually with machine learning stuff. Because Python is not very fast, it does around 250,000 requests per second using their HTTP implementation. ASP.NET is way above that, it's way faster and more scalable, so that's pretty cool. So, what can you do with ML.NET? Well, there's a bunch of stuff that they thought about that you should be able to do. So when we talk about typical machine learning problems, then it's stuff that's not easily done by using if statements. So for example, if I want to classify an image saying, hey, this image is a broken tool or this other image is a good tool, I could try to compare the pixels, but it doesn't work. So you can use ML.NET for that to read in the image and build a classification model.
Because doing that with imperative code would be really hard. It is doable, but it would take a lot of code and a lot of design to make this work.
And the error margin is so huge. Well, for me, it's impossible. I don't know any other way than using machine learning for that. Another cool thing that the Microsoft actually demos on their website is labeling GitHub issues. What happens is they read the text in the GitHub issues and they can automatically assign areas to each of the issues. If you've got a GitHub repo that's very large. For example, you're running a .NET Core framework team. You've got several teams working on the same repo, and then assigning the issue to the correct area, that's a challenge. Not everyone is very clear on where an issue is happening, so this is a cool trick. And there's a bunch of other stuff that you can do. So these are just ideas. And what's good to know, there's a bunch of samples on GitHub and stuff on their website. That gives you a guide on how to do this.
Yeah, we will add these links to the show notes so that people can find
So one of the samples here is image classification, and you've also got the custom vision service now in cognitive services. So how do these offerings compare? When would I use a cognitive service versus ML.NET?
So the thing is, cognitive services already made models. So you basically buy the model from Microsoft. You're paying a license to use it, but you can't change the model. And these models are trained against datasets that are pretty standard. So foodstuffs, landmarks, tools.
Also pretty generic.
Yeah, it's pretty generic. And they're pretty good still. So they can recognize up to 95% of the cases, which is really good for image classification data for a model. But let's say you've got something like, I want to detect which type of screw I have to put into a certain part.
So you're in a very specific domain.
Yeah. So this is all domain specific. Actually, when I talk to people about machine learning and using that, I would say start with cognitive services first. If that doesn't work, then this is an option. So today what we're going to do is we're going to build a model using the model builder. What actually happens underneath the covers when you build a model in ML.NET is that we're going to build a machine learning pipeline actually. So data comes in and something happens to the data and an answer comes out. So for example, I could put in properties of a taxi trip, and then out comes a predicted fare for that trip. I could have. So what happens when you initially read data into this pipeline, it needs to be transformed into numeric values. Machine learning is actually a trick where we use mathematics and trained parameters in a mathematic formula to come up with a good answer. So it's all numbers. Some people say it's stupid as a brick, but I think it's slightly above that one.
And is this also why, for instance, a GPU or some specific CPU unit can help you with ML? Because it is all numbers and mathematics and matrices and stuff like that, right?
So what happens is when we build this pipeline, we build a bunch of transformers that help us get the right numbers for the model. And at the end, there's an estimator, which is the model itself that we're going to train. And how this works, this training is, we provide it with a sample and the correct answer, and we're going to try to change the parameters in the model so that the transformation that we're doing inside the model matches the expected answer. Obviously, it won't be right the first time. So you have to try over and over and over and over again.
That is the training part.
That's the training part. So that takes a long time. So you have to do thousands, millions of calculations to come up with a good model. And that's why you want this to be very fast. So we all know that C# is very fast, but it could be faster if you're using C++. Because that takes away the whole virtual machine thing. ML.NET features an internal API that's highly optimized for this sort of operations. So it uses all the CPU tricks that are available to a computer to train a model. So it's a pipeline so you can stack multiple transformations to your dataset to pre-process the data to a model, and then the model gets trained. And because this is a pipeline, I can then use the same trained pipeline to make a prediction. Because if I say I've got a value between 0 and 100 and I want to scale back using the first transformer to 0 and 1, I have to do the same thing during prediction. Otherwise it will predict trash. That's the problem. So this pipeline you can save, and then you can make a prediction using the trained pipeline afterwards. So this is the general idea of what you're doing in a ML.NET application. So for this demo, I'm going to predict the price of a trip with a taxi. I've got a dataset for that. That looks like this if I open it up in Visual Studio Code. So it it's a CSV file, and it has several columns: the ID of the vendor, a rate code, passenger count, trip time, trip distance, a payment time, and a fare amount.
Is this some real-world data or some sample
This
data?
is an open dataset, so it might be faked. I haven't been able to check that. They put this up on the website. Microsoft provides this sample dataset. it's pretty cool to try out, but obviously it's not the best idea to use it for production.
And is it correct that this data set contains the parameters, but also the outcome that you expect? The fair amount is basically what you want to predict later on?
Yeah, so when we talk in normal developer terms, this would be a table where each row is a row in a table, and each field is a column in the table. Yeah. In machine learning terms, the first set of columns that I have here are called features for the model. This is what it tries to learn.
Trains on.
Mm-hmm. And this is actually the output of the model.
Okay.
So how many rows do you have in here?
It's 23 megabytes, so there's a lot of rows in here.
It's a lot, yeah.
It's over 100,000 rows. So it will take a while for the computer to...
Over 1 million even.
Yeah.
Yeah.
So that's a lot.
Yeah.
But that's good. The more samples you have, the better it will understand what the data looks like and recognize a pattern.
Yeah.
That's what machine learning is all about, recognizing a pattern in the data. So what we can do now is we can fire up Visual Studio and we can say, well, I've created a console application, and to this console application I'm going to add a model. What I can do is I can right click on my application and I can add a machine learning. How do I get this wizard? So this is an extension in Visual Studio. You can download that from the marketplace. It's still in preview, the model builder, but this is working pretty well at the moment.
Okay.
And it supports Visual Studio 2017 and 2019.
Okay. And not Visual Studio Code? Only
No,
Visual Studio?
no, it doesn't. There is, however, a command line utility that does the same thing.
Okay.
But I like to use the graphical version here because that's what I think most people will start with.
Makes sense.
So when I open this wizard, I've got an option of choosing a type of scenario that I want to use machine learning in. In my case, I want to predict the price. So I can click this and it will ask me for a source. And in ML.NET I can use a file as input or I can use a database as input.
Okay.
So
And this type of scenario basically determines the algorithms used by the model?
Yeah, so this will produce a regression model, and regression model is typically used for predicting continuous values. If I would classify issues in a file or predict sentiment, that's a classification problem. Okay. So it's either A or B or maybe A, B, C. So what I can now do is, I've selected my taxi fare file. I can pick the column fare amount. This is the column that I'm going to predict.
Okay.
And I can select input columns. So I can choose which features I'm going to use to predict my fare amount. In this case, I will leave everything on. I don't know any better. That's basically it. That's what a typical developer would do, I think. So it says, I've got over 1 million rows, and it's 7 columns, and you get a sample over here, so you can check if it's anything good. So the next step is to train the model. I can specify how long are you allowed to search for a good model for me.
Okay.
So what will happen when I start training, a process is kicked off that will try several models against my data. This will take 10 minutes. I've got a version that's already done. But this is going to try several models. And as you can see here in the output window, it will try different types of training algorithms to come up with a model. And what happens is, over here you can see the scores for the model, how good it's doing. So in this case, it's 95 cents off from the actual taxi fare. That is pretty good.
And so you've just given it this single data set. So does it split that automatically into a training and a test set? Yeah,
it does all that for you automatically.
Nice.
So that's pretty cool.
Yeah.
So we'll leave this running. This will take 10 minutes, so that's a long time. In the meantime, I've trained one in my other application, and once you're done training, you will get the option to create code. So I can say, I can train it, then afterwards I can evaluate my model, so I can actually try different samples and see how that works for me. I get a sense of how my model is doing. Actually, for a regression model, you're more interested in how much is it off. So in my case, how many cents am I away from the actual fare that I pay?
Right. Yeah.
And that's the amount that I have to pay extra to the taxi driver. So once I'm satisfied with this, I can say generate me some code, and I can click this button and add the projects to my solution. What happens when I click this button is that I get a console application that's basically a sample for the application, and I get the model. the model is stored in a zip file in a separate project, and together with the model, there's a model input which defines the features that I've put into the model, and a model output class that defines the output.
Yeah. So that zip file, is that just another Onyx file or some other standard?
It's a proprietary format,
okay.
So they're not using Onyx for this.
Is there an option to export it and to maybe give it back to my data scientist?
Yeah, there is. Yeah, so you can export it to Onyx. The downside to that is the data scientist can't modify the model anymore.
Okay.
It's in Onyx. So it's one of the
They can
challenges,
evaluate it, but not change it.
Yeah.
Okay, makes sense.
So another cool thing that's in there, that's the consume model class. So what happens when I want to make a prediction using this model, I first have to fire up an ML context. This ML context is a central context for ML.NET. And it's actually the source where you can load data, do pre-processing, basically build a pipeline.
Yeah.
So in this case, I'm saying, well, I've got this model file in my project, and I'm asking ML context.model.load the model from disk, and generate an output schema for me.
Okay. So if I would publish this application, must make sure that this zip file is published with the application.
Yeah.
Into the output directory.
Yeah. So in this case, it's a resource in my application.
Yeah. Okay.
So it's automatically copied to the output. They made sure that the project is configured as expected. So basically what it says, it's non-copy to output directory.
Yeah, okay.
So I can use this in my application to make a prediction. And it's all strongly typed too. Yeah. So I've got my basic properties. Let me show you how that is actually used. So what I can do is I can say, well, first, make a data sample. In this case, it would be in this method where it says load a CSV file from disk that contains a single row of data, and convert that into the model input class that I know. And then I can use the consume model class and call predict on that to use that. So what you could also do is say, well, not everyone uses CSV file as the input. So what I can also do is model input is new model input. And I can obviously load this from JSON in a web application, or I can do other stuff that this works with.
Nice.
So that's pretty cool.
Or you could ask the user to enter some data and then predict the fate.
Yeah, so this works for WPF, this works for Windows, Universal Windows apps, this anywhere you want. So you can provide the input and then also send back the output to your application and interpret that into something that's useful for somebody.
Pretty nice.
Yeah, so one of the cool things the last thing that I wanted to show is how do you use this actually in a web application? This is a console app, this is the Hello World. Yeah. Let's build something.
Now go to Hello Cloud.
Yeah. Hello Cloud, yeah. It will still be limited, but let's show how this works. So I've got an ASP.NET Core web application. It's web application 1. It's in a new folder. In the other one it would be 98. So I can say, well, let's do an API application. I don't want anything else. Let's assume this is a microservice that I'm going to deploy to production.
Yeah.
So what I can do now is I can say, well, let's add a reference to my model project. Say, okay. Then there's one more dependency that I need to run in a web application. I can say, let's search for ml.net. And there's a Microsoft extensions ML. So people that are familiar with ASP.NET Core know that Microsoft built this Microsoft.ASP.NET Core.star, all the packages, but they also built Microsoft.extensions.star. And those are extensions to the .NET framework. In this case, the Microsoft Extensions ML is an ML.NET extension for .NET Core.
Okay.
What this contains is a scalable ML context, because the normal ML context is not thread safe. So what happens if you use that in a web application, it will break. That's why I'm showing this. So I've seen people try this out and it broke on them, so that's pretty bad. So what I can do is I can say services.add.
So it already also ties into the CI stuff that we have in ASP.NET Core.
Yeah, so there's an extension method. dependency injection. It's using that for...
nice.
Let me quickly find the method, what it's called again.
A lot of extension methods.
Yeah, it's sometimes very hard to find out what it is actually doing. Prediction engine pool. So this actually creates a pool of prediction engines. Okay. And I can say, well, I've got this a model input class that I want to insert into, and then a model output class that I want to get out of that. And then I can say, from file, I can specify a model file. So I can say, well, I've got this, let's say mlmodel.zip.
Yeah.
mlmodel.zip. And that's basically it, what I need to do. So now I can grab my controller and I can say, let's create a new controller for this one. We're going to predict the weather using static data, and then we use fancy machine learning to predict the taxi fare. Taxi fare controller.
That's fair.
Yeah. So in this case, I'm creating a new controller based on a controller base because I'm not using views. I can say async, I task, I action result, model output. Because I want to give back the prediction. Predict, model input, input. So in this case, it accepts a body that has all the stuff. So let's fix all these references up for me. ASP.NET's acting up for me.
Just the action result.
Yeah, maybe it's just action result. That's working. Yeah.
You use the abstraction, but you don't need that.
Private read-only prediction engine pool. Model input, model output.
There's a refactoring for that.
There is. Get prediction engine. So I can ask for a prediction engine, which is pretty much the same as in the console application.
Okay.
So I can store that in a variable to make it easier for me, and I can say prediction engine dot predict input, and I can return it. So
is that an expensive call? Something you need to cache?
No, the prediction engines you just shouldn't cache. So the pool you cache, that's a singleton actually in your application, and it will reuse instances across the request. So you can increase and decrease the size of the pool as well, but for the most part, leave it standard and it will work for you.
Okay.
So it took me a couple of lines of code to fire up the prediction engine pool, and then I was up and running in 2 lines of code, and this is how it works for ASP.NET.
Pretty nice.
Nice.
Yeah. Now you made this an async method. Is it also an async prediction, or is that not possible?
That's a good question. I don't know actually. In my case, I don't think,
because I can think this could take some time, or
it's not actually async. So it's a sort of a habit of me to make everything async these days. But
that's why I was interested in that, because that would make sense to make it an async call and then free up some threads.
I guess that depends on the size of the model, right? How long this call will take.
Yeah, typically your model on disk is not very large, so I can actually fire that up for you. I can say, open this folder in Explorer. It's 75 kilobytes. So versus 23 megabytes of data. So actually, once you've done all the computation and spent all the time training this model, then it's very fast afterwards.
Cool.
Yeah.
Nice.
So that's it.
Pretty easy.
Yeah.
Cool. Yeah, I'm really impressed with how easy and how fast it is to get going with this stuff.
Yeah, it's pretty cool, I think, for C# developers. This is a massive step, I think.
Yeah.
Yeah.
Very nice.
Nice.
Well, I hope you liked it too. And till the next one. Goodbye.
See ya.
Bye-bye.